Welcome once again. So yesterday was a big bang start to our Learnathon, 100 days Learnathon. We're all very excited about this because if we don't take something, a grand initiative like this, then I think we will stay comfortable, complacent, and do only what we are doing. So this is a good initiative for all of us. Um, and I wanted to start with a little bit of basics of AI. Even the basics of AI you can cover for a very long time, lot of hours you can talk about it. So within this next till 3:20, 15 minutes, I'll just try to touch some basics. Each of those items can be taken up by someone, and they can learn about it. They can come and talk about it. So there is a lot of scope for everyone to do a small part and make a dent in this world of AI. So everybody knows this image, right? So this is Boston Dynamics. This is a company in USA. They do a lot of these robotics, and the robots are fitted with a lot of sensors, a lot of AI models, one for vision, one for speech, and all those things. So I just thought that will be the good start. And I am not a computer student. I was a biology student. So I love taxonomy. Like you have flora and fauna. Under fauna, you have animal kingdom, you have all the way till your genre and species, right? So similarly, I wanted to go ahead and do that for where we stand with AI. So I took computing as the topmost item, okay, the king of that kingdom. Inside that, you get multiple disciplines. You get computer engineering, software engineering, computer science, information systems, and information technology. Computer engineering is coming up with the art of creating a computer, the processor, and all those things. That's a separate discipline. Software engineering is the one that we are all in. We create systems, we architect systems, front end, back end, whole systems, and all those things. Different software methodologies, best practices, principles, all those things comes under software engineering. When you go to computer science, then all the BE computer science guys, you would have learned about discrete mathematics, and then number systems, hexadecimal, decimal, binary, all those things. Then you will jump onto operating systems, algorithms, data structures, advanced computer science, they will read cryptography. Then when you take these computers into the world, you have information systems for large companies and information technology, which is again a combined term for multiple things. So this is the vast area of computing as we know it. So where does AI stand? If you may ask, I was thinking about it, and I think it's somewhere it's cutting in the middle. It's a cross-cutting discipline because you need a little bit of computer science. You need to know programming. You need to know algorithm. You need software also, because AI, when you talk about AI, it needs to be usable to the end customer in a form of a service, in a form of a package service. So how do you deliver something to a customer? In the form of software, in like a website or a SaaS platform where people can log in and get that service, right? So when you talk about AI in total, it also involves some software components in the front and the back. And also certain AI needs specialized computing. So the first block is also being touched. So in summary, what I would say is AI is a cross-cutting discipline which cuts through multiple areas of computer science. Specifically, you will be doing more stuff in algorithms, which is pure computer science, but you will also do a little bit of additional peripheral software and computer engineering. Now, going into artificial intelligence, so we saw that higher order, then we are coming narrowly into the artificial intelligence. So all the pages that you go to, they give these three definitions. There is weak AI, there is strong AI, and then there is super AI. So the weak AI is also called as artificial narrow intelligence, ANI. The strong AI is also called as artificial general intelligence. And the last one is ASI, artificial super intelligence. I was surprised to learn that all the things that we are seeing on a daily basis actually falls under weak AI or narrow AI, because it does only one thing. For example, take Siri, Alexa, Cortana, all these are talking devices, right? You get a Google Home or a Alexa a device that you keep in the living room. Hey, Alexa, play latest Tamil hit songs. So those devices they say they are AI, but mostly they are software, they are hardware, and there is a small AI component sitting somewhere in the server. It does only one thing, maybe plays a song, maybe finds a restaurant, something like that. And take, for example, email spam filters, which are AI filled. They have, language profanity filters, which will filter out any bad words or any malignant email that comes with a bad link. Chat bots, even self-driving cars. I was thinking self-driving cars is one bit advanced, but apparently not, because all it does is it has cameras or radar or things like that, and it is only supposed to do one thing: run one particular machine learning algorithm and try to find what is the distance between me, this car, and the next car. Is it coming shorter or is it farther? Figuring those out. So that also comes under artificial narrow intelligence or weak intelligence. Google autocorrect, like if you are typing your Gmail, as I am suffering from, and then it'll give like fever, please grant. So it'll try to predict what you are trying to type based on the previous sentences. So that's all based on AI ML models that's sitting on Google, again specifically for one particular purpose. When you go to Amazon, it gives you a lot of recommendations: buy this stuff, that stuff. That's all based on ML models running behind, based on my user profile, what I have bought, what people around me in Mogapair have bought, what people have bought in the second week of March. Based on these different inputs, the models will keep running, and it will give out predictions and recommendations that comes. So surprisingly, all this in the past 15 years, whatever we are enjoying in the name of AI is all artificial narrow intelligence. So what is strong AI? So I was surprised to know that it's actually very much in its state of infancy. And the buzzword, the relatively new buzzword, ChatGPT-3, is considered to be strong AI, because Jerry might go to ChatGPT and ask, "Give me the ingredients for sambar." It has to understand that sambar is a dish, and it has to go into its knowledge base and retrieve it. Whereas another person, developer, will ask, "Give me a program to write Fibonacci series." So it has to have some general intelligence that what is this person asking? Where can I go and find it? How can I the found answers? How can I create it in a readable English language? So it does multiple things. It does not do one thing. So that's why they are classifying that as artificial strong intelligence or artificial general intelligence. It has intelligence about multiple items. And the third type, super AI, they say we have not reached there, which is the stuff that we see in Hollywood movies. It's sentient beings which can think for itself, which can rationalize stuff and all those things. We do not know if it is already created. Maybe it lived for a few seconds, suddenly they turned it off. That's what you learn from the news, right? It became self-aware, so they had to turn the computer off. Because if it becomes self-aware, you don't know what will happen. Maybe it will try to take control of all the computers in the network, all the computers, or it will try to make a copy of itself into another network in a different geographical area. So it could do anything. The cons of AI we do not know. So the third category, we don't have anything labeled as artificial super intelligence as of now. So we can very well actually start learning about the narrow AI and how we can make better use of it. Okay. So we saw the taxonomy from computing. Then what is artificial intelligence? Inside artificial intelligence, you have this machine learning. So where does this sit in machine learning sit inside AI? You are able to go and buy a Google Alexa, Amazon Alexa device, and use that artificial intelligence in your home. So when you take this science, this ML science, and package it into a product or a service, that's AI. So if you go back, all these are sellable, purchasable services: Siri, email filters, chatbot, self-driving cars. Whereas this is pure, algorithms and pure scientific things, which is actually plugged into your AI stack. Your AI stack has a hardware, a software, a cloud component. Somewhere in that stack, this machine learning model comes and sits. So I hope that you need to have that basic understanding of where things fit. So machine learning fits there. And ML, all the classical textbooks, they talk about you have unsupervised learning, supervised learning, reinforced learning. Pretty much we are, by the time of 5 years old, a child can, know that this is fire, know that this is what is kept on a plate is food. That is general intelligence it's building. But basically what's happening in a human brain is we are developing our own learning algorithms. So we are not a machine, we are human intelligence. We are kind of making our own algorithms and models. So I will, in a few slides, I'll talk about algorithm versus model. And internally, we don't know how to give names to these different models our brain stores, but we unconsciously we use all those models, and that's how these people are able to think about those models and see how we can represent them in mathematics and in computer science, and so that we can, what we are able to do, can we give the capability for a machine to do. Okay, so supervised learning has a lot of machine learning algorithms right now. These names, unless somebody has already learned stuff about it, it'll look Greek and Latin. But each of those different algorithm does a different thing. One needs a lot of input to create some intelligence. One needs very minimal input to create intelligence. One needs somebody to help it understand, hey, I am deciding that this is the correct answer. Then human has to say, yes, you predicted it correctly. No, you did not predict it correctly. So that is supervised learning versus unsupervised learning. Then there is reinforced learning, like when a child puts a mathematics problem and you pat on a back and you said you did right thing, then it will learn, like, if I take this approach, then I am doing right. So the algorithm also, you can reinforce it with suggestive answers that you are doing good, so it can better its performance. So there are different types of ML algorithms. Again, for the sake of clarity, ladies and gentlemen, this is a science on its own. So if a person wants to learn about everything about machine learning, they can spend considerable amount of time learning about all these different algorithms, which one should be used. So an ML engineer, their duty is to completely learn all these different, maybe 30, 40 algorithms. They will know what to pick. It's like a toolkit. You open the toolkit, you need to know whether to use a screwdriver or a hammer. So all these different tools are there. An ML engineer, AI ML engineer will know which algorithm should I pick for which task. Whereas we are in a plane where these tools are now wrapped under services and provided by several service providers. You have Amazon, you have Azure, you have a lot of service providers, which this panel will slowly try to bring to our forefront, right? How can we use those packaged services to achieve our business goals? I think that is where we should start. Otherwise, this will be like going back to the blackboard and trying to learn the ML. Nothing wrong in learning them, but first let's try to get ourselves easy with the usage of AI. Then we can know, okay, under this AI services they are using this ML. Let me actually try to learn that ML. So that's the place I kind of differ from Solomon's viewpoint yesterday, that he said we can write our own ML algorithms. But I think if we are kind of crippled and we do not know what to do, we can readily use the freely available or low cost AI services and get our problem solved. Then we can go into learning the ML algorithms. That's my personal opinion. You can consider that. So I want to do a live demo now. Anybody, can you tell me what could be the age of the guy in the pink shirt?
23.
Hmm?
23, right?
Who's this?
I'm Jagdish here.
Jagdish, tell me.
You're asking the age, right?
Age, the pink shirt.
The pink shirt might be 23 to 25.
23 to 25. Anybody
30,
else?
30 years.
30 years.
30.
32.
32.
Yep.
Does he look 32? Okay. Good. There are not too many outliers, right? Nobody said 60-year-old. Nobody said 5-year-old. People said 20 to 30. So what your brain just did is it was trying to extract features from this input data. You are trying to remove the noise, the police wala, all those guys, the blue shirt culprit, you are filtering, you are taking only that guy, you are removing the noise, and then you are trying to take some features. What is this? Does he have more hair? Does he have thin jawline? So based on those inputs, you have a predetermined algorithms in your mind, which says, if he is like this, he should be 19-year-old. Usually in the police station, they'll ask, திருநவன் எப்படி இருந்தானா ஒரு 35 வயசு இருக்கும் சார். How do they say that? Because there is an ML model running inside your brain, which kind of predicts it, right? So how does, okay, your brain did this. Now, how do you make a computer, an ML program do this? That's where, you will use one of these ML algorithms, which has its own unique characteristics. So to put it very simply, if you take a three-dimensional axis, you have x-axis, you have y-axis, you have z-axis. Okay, so you are taking 10-year-old. So 10-year-old is on x-axis, and then who know one language or two language. So the y-axis is one language, two language, three language, and the z-axis is their height. So if a boy who is 10-year-old who knows two languages and he is 140 centimeters, he is going to be here. I'm talking about the XYZ coordinate. He's going to be here. So if you take all the people in that class who have taken Tamil and English, mostly all the boys in the class will be clustered around here. So now comes the most important word, clustering. So all these algorithms looks for clusters. So if you have only X, Y, and Z, it is easy to visualize. The 7th standard boys are here, the 9th standard boys are here. You will have clusters forming. But what if there is not just X, Y, and Z, but there is 20 variables, X, Y, Z, A, B, Z, so many things. So now that data point becomes a 20-dimensional data point. It will have X, Y, Z, comma, A, comma, B. So you can't visualize that, but it's a multi-dimensional space. In that space, all those data points will go and cluster in one place. So how can I explain this? If I take a photograph of you 5 different days, different lighting, and I extract features out of your face, your eyebrow length, your temple to nose point length, your lip length, your complete head length, these are features. So I already have taken 4. I can actually take 21 features from your face. So my pictures on a red shirt, in a sunny day, in any of these days, if I take all those data points, 20 data points will try to cluster around one space in that multi-dimensional space. If I take James' picture, if I take Prem's picture, it will be in a different space. So now suddenly if there is a new picture coming of James, then if I take those 20 features and try to plot it in that multi-dimensional space, it will go to that cluster where previously James's images were there. That is how an algorithm will say this person actually is James. So if it already has a database of several images and you are implementing a camera in the front of EC group reception, which takes a picture and it will extract out the features, remove the noise, extract the features, and then run this algorithm, it will tell there is 93% probability this person is James. There is only 5% probability this is Arun. That is basically a ML model, which will give you predictable results with degrees of accuracy. Okay, so this is naive Bayes classifier. So difference between what is an algorithm and a model. So you have data. My photograph is data with lots of zeros and ones, and you extract all the features. The algorithm is the process in which you will take the data, clean up, remove the noise, extract features, do some preparation, and then allow it to pass through a program, and then finally come through. That entire process is called algorithm. At the end of it, there is a intelligence created. So you can ask it, in the photo James on பார்த்து சொல்லு அப்படின்னு கேக்குறீங்க. That intelligence is the function of X. That's the brain, the small brain that you have created. So we have all these different intelligences for different functionalities. But this is a machine learning which takes data, which does a set of processes, arrives at a small intelligence, which is the model. So that's what when people say we have to retrain the model, then it is not correctly predicting. You have to run it again. Okay. So this is I just a shameless plug of my work. The work that I did 20 years ago was a face extraction, facial recognition. So that was my lab, and these are my lab mates. We will take different photographs at different lengths, 5 feet or from a cross-sectional picture. And then based on that, we will allow it to run through this naive Bayes algorithm. It will predict this person 90% probability. This is person A, person B, something like that. So it was a good thing for me to go and find these images and refresh myself of what I learned 20 years ago. So I think that's my 15 for today. Thank you everyone.